Hello and welcome, guys. So today we're going to talk about a couple of definitions that I want to make sure you guys have. Basically kind of mixtures, compounds, and molecules. What do all those mean and how do they connect back to what we were talking about last week? So that's going to be the basis for the video. It's going to be a little bit of vocab heavy, but on that note, let's just jump right in. Okay. So make sure that you have this in your notes somewhere, because your book, in that activity that we talked about, it is a little bit confusing. They don't really do a great job of explaining this. In fact, they kind of, I think, are a little bit wrong. And here's the reason why. Your book kind of makes it seem like molecules and compounds are essentially the same thing. And in reality, they're actually not. So let's start with molecules. Molecules are a little bit more of an open definition, okay? So molecules are going to be when two or more atoms combine through bonds. I'm going to reword this actually. When two or more atoms are bonded together. Let's just leave it there. Keep it simple. All right? So those atoms that we're talking about there, they can be two different atoms, or they can be two different atoms, or they don't have to be two at all. They can be more than two. So all of those things, a molecule is going to be when you have more than one atom close together. So look at this picture to the side here. This picture, it shows, this is an example of an oxygen molecule, okay? We would show that as O2 because we have two oxygen molecules that are bound to each other. However, we would not consider this a compound, and here's why. A compound is going to be a little bit different. So a compound is a specific type of molecule, okay? So it's a specific type of molecule where more than one element, I'll scoot this over in a second, more than one element is involved, okay? So it's not just the same type of thing. It's going to be more like a different things going on here. So water would be a compound. Example over here, we see carbon dioxide. So I would say this is CO2, meaning I have one carbon atom and I have two oxygen atoms, and they're all going to be through covalent bonds. Interesting thing here, though, is if you look at the covalent bonds, these are actually a little bit different than the covalent bonds that we talked about before, because these are actually going to be covalent double bonds. And we'll talk a little bit more about this later on in the week in probably the Zoom sessions. But I want to make sure we got the vocab first before we move on to anything more complicated. So then that brings us to mixtures. What is a mixture? So a mixture is going to be when you have things that are brought together that are not held together by a chemical bond, but they might be dissolved. That's not the same thing as having a chemical bond. So that's going to be the key difference here, is you have more than one substance and there are no chemical bonds between those substances. Now, there's chemical forces, there's things that are going to be interacting, but it's not the same as a compound. So there are two types of mixtures, okay? Homogeneous and heterogeneous. And if you get into the Latin of these, and this helps you a little bit in science in general if you break down the words so that you know what they mean. Homo means same, hetero means different. So homo meaning it has the same proportions of all of the ingredients throughout. It's going to be really, really hard to separate what is in a homogeneous mixture. An example that we would use would be something called a solution. So solutions are when we have all of those ingredients at a definite ratio. So it's going to be like 2-to-1. It's a definite ratio. Example down here of a homogeneous mixture would be right here. Okay. So if I make my coffee and I put a little bit of sugar in it and I put a little bit of milk in it, I swirl it around, it changes color, it all kind of blends together. I can't then go back in and be like, oops, I put too much sugar in, and then take that sugar out. So it would be something like that. Or if you do the same thing with tea or any of that kind of stuff. Now, the second type of mixture, the heterogeneous mixture, is when you have different proportions, and it's usually easier to pick out those at least two of those different things. So look at this example down here in the second box. You have two things here. First one is a party mix, like Chex Mix or something like that. You can very clearly pick out the pretzels. You can pick out the little checkery things. I don't really know what those are. I guess Chex, are those what those are called? I don't know. The little bread things. You can pick all of those things out of the party mix. They put soda here as another example because you have two parts. You have the part with the carbon dioxide and the foam, and then you have the second part. If we just had the second part together, which is like the flavoring, the soda itself, the liquid part, then that would be homogeneous. But because we're including both the top foam part and this bottom part, we would consider that heterogeneous. So that's a little bit of vocab for you. Maybe I'll make a Quizlet or something just so you guys can remember this stuff. Now let's move back into our covalent bonds just to review. All right, so I'm going to spend some time going over covalent bonds in a little bit more depth because some of you guys were confused on the last one. And I want to kind of make sure that we get this. So the main idea here is covalent bonds are going to be bonds where electrons are shared. So instead of transferring them and creating ions and a positive and negative energy, we are sharing those electrons. And this happens because of the way those electrons are arranged in the outer shell. So there are three types of covalent bonds that we find in nature. And I think the Actively Learn started to introduce you to them. So we have our single covalent bonds, we have our double covalent bonds, and you guessed it, we got our triple covalent bonds. So this has to do with how many electrons we have in those outer energy levels. So your Actively Learn use the word orbital. Don't get confused by the word orbital. Don't worry about that for now. It's something that's a little bit more complex. It's basically kind of like a sphere of where we think we can find these electrons at any given time. So let's start with our single bonds and just kind of go through that. I'm going to work with something called methane. So methane has a chemical formula of CH4. So that means if we break down our chemical formula, we should have one carbon atom and 4 hydrogen atoms. Okay, so you might want to have a periodic table up at the same time so you can kind of follow along with me why I have that many electrons as I'm making these. I'm going to do this two different ways to show you. I'm going to do once with the Lewis diagram, and I'm also going to do the Bohr diagrams for those of you guys that like that. So I'm going to put my carbon first, okay? Let's do Lewis diagrams. So if we look at our Lewis diagram, we would know that carbon is going to have 4 valence electrons. It has an atomic number of 6, but 2 of those, remember, are going to be in the first energy level. So that's carbon when it's neutral. Now, we're also going to draw hydrogen. Hydrogen, I'm going to draw it over here, is going to have 1 outer little electron like that. Now, that's not a full valence shell. You would need 2 for hydrogen, and carbon needs 8 total around it. So what's going to happen here is I'm going to erase this and draw it a little bit closer here, is hydrogen is going to share that last little electron with carbon there. Then we're going to do the same thing on all 4 sides. So we're going to do something like this, like that, like that. Now I can erase this and just draw this as lines if I want to make this a little bit cleaner. So if I want to make this cleaner, you're just going to do something like this. Bum, 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 bam. That is going to be methane. Each line represents 2 electrons, so a single pair. So everybody is happy in this scenario. Another way that you could show this is you could draw out your Bohr diagrams. So I'm going to try to do that here. So I'm drawing this kind of small here. So carbon has an atomic number of 6, so I got 2 in the first energy level. I didn't draw those over there on my Lewis diagram, but I am on my Bohr diagram. Now remember, valence, I got 4. 3, 4, okay? So there's carbon, 6 electrons total, and I have, I didn't draw my protons, I didn't draw my neutrons, just for the sake of time. Now hydrogen is going to just have 1 little energy level, okay? And it's going to look like this. Now, all it's going to do is it's going to move that little electron over. So it's going to move this whole thing, and let's go ahead and draw this together. So what you'll get is it's going to share this electron here. Bam. Draw another circle here. And another electron. And bam. So those are all single covalent bonds. They're called single bonds because each atom is contributing one electron between the two of them. So it's not adding anything extra. Each one is contributing one. So let's go ahead and look at some of these other bonds that we have. Let me erase my board real quick so that you guys can just kind of follow along with me. Or actually, let me pause it while I erase so you don't have to stay forever. Wonderful. Now that my board is cleared, let's talk about the other two that we haven't really spent that much time on. And those are going to be double bonds and triple bonds. So that happens when you have more than one electron being contributed from each atom. So triple bonds are going to be super, super rare. Double bonds are a little bit more common in nature. So let's look at an example here of carbon dioxide. Carbon dioxide looks like this, CO2. So breaking down that chemical formula, we have one carbon atom, and we got two oxygens. Okay, so carbon, as we know, it has an atomic number of 6 and it has 4 valence electrons. So if I were to draw the Lewis diagram for carbon, it would look something like this. 1, 2, 3, 4, exactly like we did before. Now, oxygen is going to be a little bit further down. So it's going to have 6 valence electrons, okay? So oxygen looks like this. 1, 2, 3, 4, 5, and 6. Now notice it needs 2 more electrons to fill its valence shell. So what's going to happen here is I'm going to take these 2 electrons and share them with carbon. So instead, I'm going to get something that looks a little bit different. So the end result is going to look like this. I shouldn't have erased carbon, I'm sorry. It's a little bit confusing, but that's okay. All right, so carbon is going to have 1, 2, 3, 4, but now oxygen is going to come in and it's going to share, and I'm also going to erase this electron from carbon because guess what? It's going to throw that in there too. Whoops, like so. And then oxygen is also going to throw all that in there. So now we got something like that. And that looks weird, but keep in mind, all 4 of these are getting shared between carbon and oxygen. Now, keep in mind, carbon dioxide, we'd still have 1 more oxygen, so we're just gonna do the same thing on the other side. So 1, 2, 3, 4, 5, 6. And so what's gonna happen here is we are going to share those 2 electrons there. Carbon's gonna move that electron to the side, if I can get it to move. Maybe it won't move. Let me just erase the whole thing. Okay, you know what? I'm just going to draw it on the side. For some reason, the eraser is not working. So you're going to get something like this. Okay, so now look, there's 4 electrons total being shared on each side. 2 from each atom, which is why we call it a double bond. So it's going to look something like this. They're all happy because even though it looks like it's more on one side than the other, they're still equally shared. So it's going to, we still have our valence electrons for oxygen here. So it's still going to be happy. Okay. So that is what it's like at the end of the day. And if I want, I can continue that over here. Because remember, those valence electrons are here. So that's carbon dioxide at the end of the day. Now let's look at a triple bond. I'm not going to ask a ton about triple bonds because they're super, super rare. So let me pause while I erase everything. Alrighty, so let's talk about nitrogen for a second. Nitrogen is a good example of something that forms triple bonds. So nitrogen is right here on the periodic table. It has an atomic number of 7, which means it has 5 valence electrons. If we were to draw out a Bohr diagram of nitrogen, it would look something like this. I'd have 2 on the inside energy level, and then I would have 1, 2, 3, 4, and 5. Now notice I have 3 spots where I can make bonds. Now I could use all of those and I could do 3 single bonds, single bond here, single bond here, and single bond here. However, nitrogen sometimes with it, when it mixes with itself, particularly in the atmosphere, you get something called N2. And those nitrogens actually bond together with an intense triple bond. Triple bonds are really, really hard to break. They take a lot of energy because they're super strong. So what's going to happen here is all 3 of those electrons are going to get shared with the other atom. And the other nitrogen atom is going to do the exact same thing. So if I draw my Lewis dot, I'm going to draw 1, 2, 3, 4, and 5. Now on the other side, I'm going to do the exact same thing. So I'm going to draw another N, 1, 2, 3, 4, and 5. Guess what? I'm going to take all 3 of these electrons right here, and then you're going to share them. So it'll give you something like this. Let me get black again. You'll get something like this. Which we simplify to say something like this. Now, count up the valence electrons just to make sure it adds up. Keeping in mind, every time you see a line between 2, you would count that as 2. So if I want to just double check my work as I'm making these Lewis dot diagrams, and again, I'm going fast, I know that. So I'm not going to ask you super intensely about double and triple bonds. I just want to show them to you. I might ask a couple. I'm not going to test a ton on it. So 1, 2, 3, 4. So I have 4 with this first one, 5, 6, 6 with the second one, and then 7, 8. So I got 8. I could do the same thing on the other side, and we know it's going to add up. So as long as you are counting those lines as 2 electrons, you can check your work as you're doing these if you're not sure that you're getting it completely correct. So that's double, triple bonds. Those are covalent bonds in a nutshell. I would make sure before you move on to these second 2 that are really tricky, I'll make some of them kind of bonus on the next Nearpod or so. Make sure that you really, really understand single bonds first. So again, like I say at the end of every video, keep in mind, just pause, rewind, rewatch, take notes, whatever you need to do to make sure you get what you need to get out of this video. Send me questions. I'm more than happy to answer them. I'm more than happy to Zoom with you. And I have 2 Zoom sessions set up for each class this week. So Tuesdays and Thursdays this week are going to be our Zoom days. Those times will change probably week to week. So just let me know. If you can't make it, again, I can find a time that works for you. All right. Miss you guys. Praying for you guys. And I hope you guys have a good week. Hope to see you soon. Bye.